Okay, this is a video on 4.3 worksheet review. So we are supposed to, there's examples up there if you want to look at them, but we're supposed to write a quadratic equation in standard form with the given roots. So remember, we're trying to go backwards. So what binomial factor would give me an answer of 3? So that would be x minus 3. So if I set that equal to 1, or to 0, then my answer would be positive 3. So it's x minus 3. So that's for the first one. And then what binomial factor? Give me an answer of minus 4 would be x plus 4. And that's an equation, so it has to be equal to 0 in standard form. So it's ax squared plus bx plus c equal to 0. That's my equation. It's got to be equal to 0. And a, b, and c have to be integers. They have to be integers. So we're going to have to multiply by something if they're not integers. Every single one of them. Okay, so this is not standard form because we're not multiplied out, so we need to do that. So we'll get x squared plus 4x minus 3x minus 12 equal to 0. Combine like terms, which would be x squared plus x minus 12 equal to 0. So this is the quadratic that has answers 4, negative 4, and positive 3. Now let's go to number 2. What binomial factor would give us an answer of 8? And that answer is of negative 8. And so that would be x plus 8. Because if you set that equal to 0, be x equal negative 8. Then negative 2 would be x plus 2. And again, set equal to 0, otherwise we wouldn't know what this is because it has to be, we would set each of these factors equal to 0 to get those two answers. Again, not in standard form, so you got to multiply it out. X squared plus 2x plus 8x plus 16 is equal to 0. So x squared plus 10x plus 16 is equal to 0. That's your quadratic in standard form that has the roots negative 8 and negative 2. Number 3. Apparently I don't have, oh, there it is, okay. 3. What binomial factor gives me an answer of positive 1 would be x minus 1. And then positive 9 would be x minus 9 equal to 0. Again, got to multiply it out. Negative 9x, negative 1x, plus 9 equal to 0. Combine like terms, x squared minus 10x plus 9 equals 0. Now you can check the answer by just taking these two roots, plugging it in for x, and making sure you get 0. If you don't, your answer's wrong. So that was number 3. Number 4. This one only has one answer, so what binomial factor would give me x equal to negative 5 would be x plus 5. But that's not a quadratic, so we have to have another binomial factor, but we can't have a different answer. So we got to have the same binomial factor because that will give us the same answer. And then this is a perfect square trinomial, so if you know the pattern, remember you'll get a 5x from this product, another 5x, a total of 10x, and then plus 25. Equal to 0. And everybody's a integer, so we're good. Number 5. Here's where it gets fun. So what binomial factor would give me, first of all, there's two ways to do this. Let's do just what we've been doing. What binomial factor gives me an answer of negative 1/3 would be x plus 1/3. And then what binomial factor gives me an answer of 5 would be x minus 5 equal to 0. Again, not in standard form, so we need to multiply it out. X squared minus 5x plus 1/3 x minus 5/3 equal to 0. Okay, so this is the part where it gets you have to do more work because they're not all integers. And do not combine like terms here. You're just going to make your life harder because you're going to multiply by something anyway. That will make them all nice numbers. So to get rid of thirds, that's our denominator. that's annoying, multiply by 3, and that'll make those wholes. So you got to multiply everything by 3. So obviously it doesn't affect this right side, so that's why it's so nice that we can set it equal to 0. Distribute the 3, so 3x squared minus 15x. And then 3 times 1/3 is 1, so plus 1x. Then 3 times negative 5/3 is negative 5. Now combine like terms. So 3x squared minus 14x minus 5 equals 0. That's your answer for 5. Now, if you know how to get the binomial factor without doing fractions here, this is how you do that if you want to do that. You can either just know, or to figure it out, you do x equals negative 1/3 because that's your answer. And your binomial factors don't have, like in a normal one, and when we factor, there's no fractions in here, so we need to get rid of the fraction here. So we're just going to times each side by 3 to get 3x equals negative 1, because negative 1/3 times 3 is negative 1. And now we're going to add 1 to both sides, because our original binomial that we would have set equal to 0, if we were actually solving this, it would be set equal to 0. So this was our binomial factor. So that's one of them, 3x plus 1, and then we still have our x, was it minus 5? Yep. X minus 5 equal to 0. And then when you multiply this out, you're going to get the same thing we got in the other one, except no multiplying needed, and you'll get the same answer. So either way is perfectly fine. You just got to know that you can't end up with fractions here. You have to change them to integers. That's it for number 5. Number 6, again, we got some fractions here. So what binomial factor gives me an answer of 2/3 would be negative x minus 2/3. And then x, what would give you x equal to negative 2/3? X plus 2/3 equal to 0. So notice this is a difference of squares. Okay, so our result's going to be a difference of squares here. So let's just go ahead and multiply this out. So x times x is x squared. X times 2/3 is 2/3 x. Negative 2/3 x. And then negative 2/3 times 2/3 is negative 4/9 equals 0. Nice things. Let's go ahead and combine like terms here because they go away. So x squared minus 4/9 equals 0. Now we can't have fractions, so we need to get rid of this 9th. So to get rid of 9ths, multiply by 9. Don't forget to distribute. It doesn't affect the right side. And here we get 9x squared, and then 9 times negative 4/9 is negative 4. So it's 9x squared minus 4. If you see that our result is one that comes from a difference of squares, you can also do it this way. We know our answer is plus or minus 2/3. X equals plus or minus 2/3. When did we have to put a plus or minus? When we took the square root. So if we're going backwards to try to get to our standard form of an equation we solved, let's square both sides. So if I square both sides, it's going to get rid of that plus or minus, because positive squared would be positive, negative squared would be negative, or would be positive. So it's just positive. So we get rid of the plus or minus sign. We still have to square 2/3, which is 4/9 equal to x squared. And then we're back at this part right here. And we can go ahead right now and multiply each side by 9. It's like we're working backwards. We had solved it, now we're going backwards. So 9x squared equals 4, subtract 4, and that's your equation. 9x squared minus 4 is equal to 0. So either way is perfectly fine. Or there's even a third way. You can know that to get just one of the 2/3 answers, it would give you 3x equal to 2, it would be 3x minus 2. And the other one would be 3x plus 2. Oops. and then multiply that out, and you get the same answer. So for that one, there's a lot of different ways to do it. Last one, number 7. This one's tricky. Well, it has two fractions, not super tricky. The binomial factor that gives me 5/4 as an answer is x minus 5/4. The one binomial factor that gives me negative 1/2 as an answer is x plus 1/2. And equal to 0. Multiply out x squared, x times 1/2 x, or times 1/2 is 1/2 x. Negative 5/4 times x is negative 5/4 x. Negative 5/4 times 1/2 is negative 5/8 equals 0. Now, look at this. We have a halves, fourths, and eighths. If I multiply by 2, it will get rid of the half, but not the fourth or the eighth. If I multiply by 4, it gets rid of the halves, the fourths, but not the eighths. So I need to multiply by 8 to get rid of this. So don't forget to multiply everything and both sides by 8. Again, it doesn't affect the right side. Then we have 8 times x squared is 8x squared. 8 times 1/2 x is 4x. 8 times negative 5/4 x is negative 40 over 4, so that's negative 10x. 8 times negative 5/8 is negative 5. Combine like terms, and 8x squared minus 6x minus 5 equals 0 is your quadratic. Again, there's another way we can solve this by figuring out what binomial factor with integer coefficients gives us 5/4. Then we don't have to do this times 8, but we do have to do a little work in the beginning. So I know that some binomial gave me an answer of 5/4. So I want to make it into a whole number. So we know they had integer coefficients, so 4x equals 5, and then it was set equal to 0. So there's my binomial factor that was set equal to 0 to solve. So that's one of them. The other one was x equals negative 1/2. Again, make it have integers in it, no fractions or decimals. So 2x equals negative 1, and it was originally set equal to 0. So it's like we're working exactly backwards. If I was going forwards, if I was given this, I would set up this equation, subtract 1 from both sides to get this statement, divide by 2 to get this final statement. So these are our two binomial factors that give us those answers. So those were multiplied by each other for our original quadratic, which we can find by writing in standard form. 8x squared plus 4x minus 10x minus 5. That will give us the same thing we found before, 8x squared minus 6x minus 5 equal to 0. So again, there's two ways you can do that one. That's it for the front page. Let's go to the back page. Again, there's some examples if you don't understand it, as well as this. So there's two, we're going to do problems, not two. I assigned you problem 3, 7, 8, 9, 11, 12, 17, 19, and 21. So I'll be doing these on the side here. I don't have enough room to do it here. So let's start with number 3. So here's number 3. When we're solving a quadratic, we need all the terms to one side. So we have to have it set equal to 0. So we can factor and use zero product property. So 20x squared plus 25x equals 0. Now let's make our lives easier. We can divide by 5. So just remember to divide each piece by 5, each term. So 4x squared plus 5x equals 0. So the only reason we can just divide by 5 instead of actually factoring it out is because it's an equation. And we can do 0 divided by 5. Now we have to factor this. Look for a greatest common factor first. X is our greatest common factor. So this would be 4x plus 5. And then that's fully factored. This isn't factorable anymore because it's x to the first power. So set each factor equal to 0. So either x equals 0 or 4x plus 5 equals 0. So we need to do some work on this one to solve for x. that will make this equal to 0. Because if that was 0, the whole thing would be 0. So that would be a solution. And if x is 0, makes the whole thing 0. So that's our other solution. So back down here, we're dividing by 4, so x equals negative 5/4 and 0. So your final answer in solution sets, negative 5/4, comma 0, least to greatest. Now number 7. So we have to factor this. It's already set equal to 0, so that's good. So we need two numbers that multiply to give me 30, negative 30, and add to give me positive 1. So 6 and 5 are 1 away, so it's 6 and negative 5 because we want a positive 1. So this one we can just go straight to factoring because the coefficient is 1. So it'll be x plus 6, x minus 5 equal to 0. So set each factor equal to 0. X plus 6 equals 0, or x minus 5 equals 0. We'll make the whole thing equal to 0. So that's a solution. So minus 6, x equals negative 6 and 5 in solution sets. And that's your final answer for 7. Number 8, 2x squared minus x minus 3. So we can factor this by grouping. We need two numbers that multiply to give me negative 6, add to give me negative 1. So it's going to be 3 and 2. So 1's negative, 1's positive. So you're looking for a difference of negative 1. Well, sum of negative 1. So that will give you negative 1. So that's what we're going to split this guy up into. It's negative 3x and positive 2x. We get 2x squared minus 2x. Just kidding, minus 3x. Then plus 2x. Still minus 3 equal to 0. Now pair them up. Factor these guys. What's common is x, so it'll be 2x and then minus 3. Over here, the common is 1, so it'll just be 2x minus 3. And what's common between both of these is 2x minus 3. And that's times by both x and positive 1. So it'll be x plus 1 equal to 0. Set each factor equal to 0. And solve. This one's the easy one. So x equals negative 1. Negative 1. And then add 3. 2x equals 3 divided by 2. And x equals 3/2. And in solution sets, least to greatest, negative 1 and 3/2 is our solution. Number 9, x squared plus 14x plus 33 equals 0. Already set equal to 0, so we're good. Coefficient here is 1, so we can go ahead and set up our parentheses. X and x, so we're looking for two numbers that multiply to give me 33, add to give me 14. So that's 11 and 3. 11 times 3 is 33, 11 plus 3 is 14. So it's x plus 11, x plus 3 equal to 0. Set each factor equal to 0. That'll give us our two solutions to make the whole thing equal to 0. So two easy ones here, x equals negative 3 and x equals negative 11. And our final answer in solution sets, least to greatest. Number 11, 3x squared plus 29x minus 10. This one we got to factor by grouping because a is not 1. So we are looking for two numbers that multiply to give me negative 30 and add to give me 29. So since they multiply to give me a negative number, one's positive, one's negative. And again, since they're 1 away, it's most likely this number in itself. Since it's 1 under, and 1 over would be a good indication that it's that number in itself. And I'm sorry, that number in 1. So 30 and 1, 1's got to be negative. Since we want a positive 29, we want the 1 to be negative. So that's what we're going to split up this guy into. So we still have 3x squared. Instead of 29x, it's going to be plus 30x minus 1x. still minus 10. Now factor by grouping. Group these two. What's the greatest common factor? 3x, and then it'd be x plus 10. Remember, if we distribute out, we'll get 3x squared plus 30x. Then over here, be careful. They're both negative. Pull out a negative. If the first one is ever negative, always pull out a negative number. So it'd be negative 1, and then be positive x, because when we distribute, it gives us negative x, plus 10, because again, when we distribute the negative 1, it becomes a negative 10, equal to 0. What's common between those whole things is x plus 10, and x plus 10 is multiplied by both 3x and negative 1. So that's factored equal to 0. Still not done, set each factor equal to 0. So either x plus 10 is equal to 0, or 3x minus 1 is equal to 0. Two answers. And we know this one is our easy one. X is equal to negative 10. And then 3x minus 1 equals 0. Involves two steps. Add 1 to both sides. Divide by 3, so x is equal to 1/3. Final answer in solution sets, smallest number first, so negative 10, and 1/3. Two answers for that one. Number 12, 6x squared minus 5x minus 4. This one we're going to have to factor by grouping, because we have 6, not a equal to 1, so it's not a nice one. But we need two numbers that multiply to give me negative 24 and add to give me negative 5. So that means that one number is negative, one's positive. We want their difference to be 5. So we have 2 and 12, either one negative. It's not going to give us 5. 3 and 8 will give us 5. We want negative 5, so it's going to be negative 8, not negative 3. So positive 3 and negative 8, that's what we're going to split that guy up into. So we still have our 6x squared, and instead of negative 5x, we're going to rewrite it as negative 8x plus 3x, because it's still the same thing. Still minus 4 equal to 0. Now we can factor by grouping. Greatest common factor of those two is 2x times be 3x, because remember we have to get up to 6x squared, so 2x times 3x would give us that 6x squared minus 4. 2x times negative 4 would give us a negative 8x. Over here we're going to they're going to group these two. What's common between them is just a positive 1. Don't take out a negative 1 because this guy's not negative. So 1 times 3x minus 4 equal to 0. Now what's common between both of these is 3x minus 4, a whole binomial. That whole binomial is multiplied both by 2x and 1. So 2x plus 1 equal to 0. Now we're factored. To solve, set each factor equal to 0. Either 3x minus 4 equals 0 or 2x plus 1 equals 0. Solve this one over here. Isolate the x like you've done many times before. Divide by 2. X equals negative 1/2. Over here we're going to add 4 to get 3x equal to 4. Divide by 3, and x is equal to 4/3. So our two answers, negative 1/2 and 4/3 in solution sets. Number 17, 2x squared plus 21x minus 11. Again, a is not equal to 1, so we're going to factor by grouping. You can guess and check here because it has to be 2x and x. Now last one, 6x squared, had either a choice of 6 and 1 or 2 and 3, so that was a lot more complicated to do by guess and check. So factor by grouping never fails. So we need two numbers that multiply to give you negative 22, add to give you positive 21. So look how they're 1 apart. So it's going to be this number in itself, this number 1 and this number itself. And we want positive 21, so it's going to be positive 22 and negative 1. They multiply to give you negative 22 and add to give you positive 21. So that's what I'm breaking that guy up into so that I can factor by grouping. So 2x squared, and instead of 21x, it'll be plus 22x minus 1x, or just minus 1, and still minus 11 equal to 0. group. I'm going to group these first two. 2x is common, so then it would be x plus 11. And then here, since this guy is negative, pull out a negative, -1, and this would become positive x and plus 11, because we distribute this negative, which will make that back into a -11. Equal to 0. Now what's common between this whole thing and this whole thing is the binomial x plus 11, and that is multiplied both by 2x and by -1. So 2x and -1 equal to 0. Now we solve, set each factor equal to 0. Our two binomial factors. Here's our easy one. X equals -11. And here's a one that includes more work. So 2x equals 1. Divide by 2. And x is equal to 1/2. Final answer in solution sets, least to greatest, -11 and positive 1/2. Number 19, 8x squared minus 14x plus 3. Again, since a is not 1, if you're guessing and checking, you have to check 8 and 1 and 4 and 2, but factoring by grouping, we can skip that. So we need two numbers that multiply to give us 24, add to give us -14. So since the product is positive and the sum is negative, both numbers are negative. So I'm looking for two numbers that add to -14. So we got -2 and -12, and that works. They multiply to give you positive 24, add to give you -14. So that's what we're splitting -14 up into, so we can factor by grouping. So it's 8x squared, and then instead of -14x, it's -12x minus 2x, and it doesn't matter, you can put the 2x first, it's fine. Plus 3 equal to 0. Now factor by grouping. I'm going to group those two. What's common? Greatest common factor is 4x. And then 4x times what gives me 8x squared would be 2x. And then 4x times what gives me -12x would be -3. Then over here again, since this first number is negative, pull out a negative. The -1 is common between them because there's actually no other number than 1. And this would be 2x because when we multiply it out, we would get a -2x. And then it would be -3 because it says +3, so I pulled out a -1. So when I distribute, it does become +3, so this is equal to that. Still equal to 0. Now what's common between this whole thing and this whole thing is the binomial factor 2x minus 3, and that is multiplied by 4x and -1. So it's 4x minus 1 equal to 0. Now solve by setting each factor equal to 0. None of these are nice. So +1 plus 1, 4x equals 1. Divide by 4 to solve for x is 1/4. Over here, we'll do the same steps, different numbers. Add 3 to both sides to get 2x equals 3. Divide by 2. And x equals 3/2 or 1.5. So our two answers in numerical order in solution sets is 3/2, which is 1/4, and then 1.5, which is 3/2. One more in this section. 5x squared plus 17x minus 12. This one, guess and check would be okay because you only have one option. It has to be 5x and x. I'm going to factor by grouping. So we got -60. Two numbers that multiply to give me -60. Add to give me 17. So one number is positive, one number is negative. We're looking for a difference of 17. So we have 1 and 60, that doesn't work. 2 and 30 doesn't work. 3 and 20, they have a difference of 17. I'm saying difference because actually one of these needs to be negative. In order to give me a positive 17, I want the 3 to be negative. So these two multiply to give me -60 and add to give me 17. So that's what I'm going to split that guy up into so that I can factor by grouping. So I still have my 5x squared, and instead of 17x, I'm going to do plus 20x minus 3x, and then still the minus 12 equal to 0. Now we're going to group them. First two, greatest common factor is 5x. which would leave me with x plus 4. So when I multiply this back out, I get 5x squared plus 20x. And then again, since this guy's negative, pull out a negative here, but we have a greatest common factor other than 1. It's 3. So we're going to pull out a negative 3, which would leave me with a positive x here. So when I multiply that out, I get negative 3x, and then plus 4. Because I'm negative 3 times 4 would be negative 12. Still equal to 0. And then what's common between this whole thing and this whole thing is the binomial factor x plus 4. What's this multiplied by? Both 5x and negative 3. So 5x minus 3 equal to 0. Now set each factor equal to 0 to solve. We have an easy one here. X is equal to negative 4. And then over here, solve for x, so add 3 to both sides. Divide by 5. So x is equal to 3/5 and negative 4. So in solution sets, negative 4 and 3/5. And that is it for this one. I do have answers to the other ones, and if you need any of them worked out, the ones I said you could have extra credit for, you'll just have to see me.